Alright, so continuing. So right, so we talk about the regular lights, regular plugs. Now, if it is for plugs that is rated at 15 amp, for the kitchen area is really 2 that is recommended. So 2 plugs per circuit for the kitchen area. 2 plugs per circuit for the kitchen area. And of course, there are other sockets or plugs that you can use that is rated above 15 amp. The regulation is really just 1 of those per circuit. And of course, the breaker will be sized based on the size plug. So you can go up to 60 amp, which is the maximum size that you can go for any plug that is used.
In the kitchen.
No, this is not for kitchen, but not necessarily in the kitchen, but for any area. So once the plug socket is rated at 15 amp, is rated above 15 amps, you can only have one of that plug on any circuit break on any particular circuit. In essence. So, alright, so in the kitchen, the plug is usually rated at 15 amp. For the kitchen, you can have only 2 of those plugs on any circuit, on any given circuit. And the circuit is usually a 20 amp circuit. Right? Now, if it is that you have a socket that is rated above 15 amp, you can only put one of that socket on the given size circuit. But this is really for specialized application. It's not generally the norm. But what is important now, for the light circuit, 15 amp circuit for the light, 12 maximum with breaker protection. For the plug, 20 amp circuit, 5 maximum, excluding the kitchen area. For the kitchen area, same 20 amp circuit, but just 2 for the kitchen area, just 2 plugs for the kitchen area. So these are normal rules that we can bear in mind. Now, even before I do color code, thinking about the drawing, because last week when we did the drawing, we saw different lines. Different lines that goes to the switch and lines that goes to the plug. Right, so I wanted to talk about that a bit. Now, for the switch, when you look at different applications, at what height does an electrician generally install a switch? What height do you think they usually install it?
You like the light switch?
Yes. So we have there's a switch here. And I'm sure if it is that you should look at most offices or even at home, this is the approximate height that they generally have them, right?
Yeah, that look like about 5 feet.
Okay. So usually, good. So 5 feet. So 54 divided by 12 is how much? So it's 54 inches.
Divided by 12 and 12 fours, 40.
So that's 4 feet 6 inches to the maximum. So if it is, so from ground level to the height of your switch, it should be, if it is that it is flush or surface, it should be 54 inches. And where do I get that information again? JS21. 54 inches. So that's something for you to remember also. 54 inches for all switches. Whether the switch is flush in the wall or whether it is surface. Always at 54 inches. How about plug? 2 different applications now. So the plug can either be surface or it can be flush. Right? So at what height do you normally see the plug when it is flush in the wall?
That's about 3.5 feet.
About 3.5 feet. Alright. And when it is surface, how much it is?
Surface.
Yeah.
Just got the same thing, almost 4 feet.
Alright, so for the plug, if it's in the wall, it should be 18 inches minimum. That's a foot and a half minimum. That's a foot and a half minimum. And the for a surface plug, it should be just as high as the switch. 54 inches.
In our class, you speak about the plug for a bit, say in case of flooding.
Exactly, right.
Not walking on the outside.
Right. So the same thing comes back to again. So you want it to be minimum 18 inches, and if it is flush in the wall, but if it is surface, it needs to be as high as 54 inches. Right, so in doing your installations, these are the little rules that you actually have to apply to ensure that your installation is safe, and those who will work or sleep or whatever in the area will also be safe. Right, so everything surrounds safety. Now, any question? No question. Right, let me go back here. Right, so let's talk a bit about color coding. I remember the question was asked sometime in one of our classes before, and I did say that we are going to look at it further down in the program. Right, so color code. So in any electrical installation, we see where wires of different colors are used from time to time. So here I brought a sample. This is 3 wires. So we have a red, a black, and a green. Where does each of them connect to? Right? And right, so if you remember clearly also when we talk about the plug, I did say that there is a live section of it is where you have the live, and the next section is where you have the neutral, and you also have a ground connection, 3 main connection. That's a single phase 110 plug, don't it? Good. So let's see what they are saying in color code. What they are saying according to the JS21 is that the color black shall be used only, and no other color shall be used for neutral or other earth conductors. Right? So they are saying up front that the wire that shall be used for the neutral conductor is which wire?
Neutral is black.
The black wire should be used for the neutral. Right? They also say that the color green or the color green and yellow in combination shall be used only. No other color shall be used for what? For earthing conductor. So they define 2 things here for us. So for single phase system, they are saying that for neutral conductor you need to use black, right? And for the earthing you need to use green. And what they are saying also is that the green sometimes can be striped. So what they are saying is that on the market you have a wire that is actually green and yellow. So when you have the green and yellow wire, they are saying you use that for the earthing conductor. So therefore, if you have a connection, you have 3 wires to connect to a plug, and you have these 3. You have a black, a green, and a red. So what they are saying, this is the neutral, this is the earth, and this is what? And this is the line. No. So therefore, if the electrician does his work according to the regulation, right, you should automatically know what is live from what is neutral whenever you pull or whenever you open a plug, don't it? Good. But the truth is that not everyone follow the code as they should. So it is always recommended for you to test. A matter of fact, in our training, they say you should treat all wires as live. So even though in your mind you are thinking that, okay, this black wire should be neutral, but I am still treating it as live until I test it for myself. Still treating this as live, though the regulation says that it should be earth. But I'm treating it as live until I test it to be certain that some mistake did not occur, or it was deliberately done for a live power to be sent to this wire.
So that can happen?
Yes, it can happen. And there are different scenarios that can cause this to happen. One is that say the electrician who is doing the work at the time he only has green wire. Right? He only has green wire. But he decided, you know what? In order for him to get pay, the plug must be connected and it must be working. What most of them do is that they use the green wire. Or if it's black alone, they have red. Black is more. They use the black wire throughout.
More grounding.
Yes, they use it as a live. They use the same color wire as a neutral, and they use the same color wire as a ground. And what they do most times is to put a little color tape so that it can easily be differentiated. But not all of them do that. So there are cases where persons have done that and they continue to do it, but it really should not happen. They want to ensure for the safety of your client and for the safety of your fellow electricians, you want to ensure that you follow the code. Clear? Good. So the JS21 provide further clarity. So what they're saying here is that for a single phase, say 3-core flexible card, the following combination of colors can be used. Right? So what they're saying for the phase conductor, for a single phase conductor can either be brown, red, and they're saying in this case it can be black also. But what makes the difference here is really the combination. Right? So based on where your equipment at home comes from, you will find that your fridge might have a black, a white, and a green wire. You remember seeing this on any of your equipment? No? Yes? You think about it. You might see a black, a white, and a green wire. Or you might see a red, a black, and a green.
Bundled up in one gray.
Sometimes bundled up in one gray card, and sometimes those are the 3 wires that comes on a fridge or any equipment that doesn't have a male plug attached to it. So the 3 wires just come out. If the 3 wires just come out, these are what you're going to see most occasion. Right? So what they're saying is that these should be the phase conductor. Or the phase conductor is really the live conductor. So yeah, but it could be a brown. So when you see a brown, most times when you see a brown, it really is referring to the live conductor. Or you might see a red, which we already established earlier that this would be the live conductor. Or you might see a black. So the black in some cases can be a live conductor. Right? So the black in some cases can be a live conductor. Now, the neutral conductors, they are saying usually we have blue, black, or white, and these are for single phase systems, which is what is used predominantly for residential application. When I go to commercial application, companies, factories, and so on, you're dealing with 3-phase setup. But for a residential, for a single phase, really predominantly residential application, you're going to have where you see a blue is usually the neutral, where you see a black and a red combined, the black is usually the neutral, and where you have a white, the white is usually the neutral. But for the earth conductor always remain green, yellow, or green by itself. Right? So the earth conductor is usually the same. No, so if the combination you're having is brown, blue, green, you know, the brown would be take the live, the blue would be the neutral. Or red, black, green, you know, the red would be the live, the black the neutral, and this one would be the earth conductor. Or if I say black, white, green, you know that the black will be the live in this case. The white would be the neutral, and the green would be the earth conductor. Right, so what you'll find is that the more you work with these, the more you do installations, is Is it more they become a part of you?
I'm not on a rush feed still. I like to start something like that.
Right.
Doing the practical can help you retain it more.
Exactly right. So even in our projects, this will come in handy. Right. So usually installation, the wire is protected by different materials. So not sure if you can see this, but based on this green wire, you're seeing two sections. You're seeing a green portion, and you're seeing the actual copper inside. Right? So what actually conducts the electrical current is the copper component. So the copper component is the section that is live. But this can be attached to a circuit, and I can easily come and touch this, the green part. Would I be shocked in such case? No. But what if I touch this copper part? Good. So this is the section that actually protects the wire. So there are different technologies or different types of insulation that is used in the industry. There are two that is popular that is used. So you have the PVC that is used predominantly in our industry, and it really means polyvinyl chloride. And you have the XLP, and this is what cross-link polyethylene. So these are the two popular types that is used, and what you will find is that the cross-link polyethylene is able to, type of wire is able to carry higher current for the same size wire. So if this wire is in, say the insulation here is PVC, this insulation is PVC, and I have a similar wire, same size, but the insulation is actually XLPE or XLP. What I find is that you can put more current through the same size XLP PE without the wire or the insulation breaking down. Alright, good. So the two popular type that is used in our local industry, you have the PVC and you have the XLP. So what will happen is that for the same size, say I have a XLPE wire. .5 mm here, right? 2.5 mm. 2.5 mm. So what will happen is that for the XLPE, this wire will be able to carry more current than this. Why? Because the insulation for this is more durable than this, than the PVC. You following? That's why it is able to carry more. No. Right. Right. More durable, more harder. Right. So what will happen is that for this wire, if it is that the
that means, hold on, sir, that means that XLP then, that means that it more, it can make it take on a more, so the example that I have the appliance in the kitchen.
Yeah.
That would have been more suitable for the kitchen, that kind of wire.
It depends on the size. Depends on the size. Right. So, for example, I'll give you a practical example. For example, many times in different installation, for example, in setting up like a 25 kilowatt generator, 25 kW gen, right? And it is single phase. What you find is that you can get up to 100 amp from it. You get up to 100 amp. But the wire size for 100 amp, and we will establish this as we continue, the wire size for 100 amp in PVC would be 25 mm. but the wire size 25 mm. But the same 25 mm in XLPE can carry 125 amp. Alright, so let me go over that. I know you're not going to get it at once. Right. So, my generator that I am installing, it can provide 100 amp at single phase. Single phase 100 amp. If I use PVC wire to install this generator, 25 mm would be sufficient because the 25 in PVC would be able to give me the 100 amp without the insulation breaking down. Following? Now, if I use XLPE wire, the XLPE wire for the same 25 mm can give me 125 amp. Right. So, say for example, the generator was giving me 125 here. Say the generator was giving me 125 ampere. The generator was giving me 125 amp. This is saying that if I use the XLPE, it would match. So I could easily use the 25 mm XLPE. But could I use the 25 mm PVC? No. Why? Because it is rated at what? It is rated at 100 amp. It is rated at 100 amp. And how much current is going to go through it? 125. So at no point would you want to exceed the amp rating of the wire. So that's just a practical example relating to the XLPE versus the PVC. Right, but it's still important for us to know the different types. They have heat resistance, oil resistance, flame retardant type of insulation, which mainly for industrial application, bauxite and those places would use that. You have polychloropropylene compound, that's PCP. You have mineral insulation, and you have tough plastic sheeted, and so on. So these are the different types that we need to know. But for now, what you can do, you probably can take note of this, do a further research on the difference between PVC and XLPE. Write it down. That's what I want you to do. Further research on the difference and similarities between XLPE and PVC. I'll give you 2 seconds to write that. Yes, 2 minutes. Alright, so you get that off? Okay. Oh, you're writing everything?
Yeah, but that's a tougher washing the terrace means.
Okay. Right, so I will send the presentation. So you can do the same once you're in Wi-Fi area, you just download so you have the info. And once you download, the info is always there on your smart device. Alright, good. So continue here. So circuit sizes. Microwave and plug circuit, just a little revision. What size circuit you would put in for those?
Microwave.
Yes. The first microwave is kitchen equipment. What size circuit you would put in for it? Or plug for it? What size plug would you put in for it? Circuit for that particular plug?
So that's plug like it's a duplex plug, sir?
Yeah, same duplex plug, right? Regular plug that similar to what we're plugged into now. What size circuit would go in for that? So I'll do this first one. So the size plug circuit is really a 20 amp circuit. Yeah. What about what size breaker for plug and light circuit? What size breaker for the light circuit?
That's a 50 amps. No, 20 amps.
For light circuit?
Line. 15 amps.
15 for the light circuit. Good. And how much for the plug?
20.
Good. And remember how to calculate the number of plugs and light circuits that is needed. Okay, good. So if it is plug, you divide the total number of plugs, excluding the kitchen area, and you would divide by how much? 5, and that will tell you the minimum amount of plug circuits that you need. And for the light, you divide by 12, providing it's breaker protected.
They say divide by the circuit
You divide the total number of lights by 12 to tell you the amount of circuits that you need.
Why choose
12
12?
because it's 12 lights per circuit based on the JS21. Yeah, right. So important principle, right? Alright, good. So let's continue. Now, lighting circuit. So the question is asked, what does a typical lighting circuit contains? Right? And we did some of this last week when we were doing our material list based on the design for the room. You remember that, right? Yeah, so the typical light circuit must have a switch. Don't? Good, must have a switch. Similar to what is on the wall. Well, this is plug. The light circuit doesn't have a plug, and it must have a what? There has to be a breaker, and it must have wires. So 3 main components. You have the breaker, the switch, wire. Right? And the other little boxes and so on that we talked about last week. First time seeing this plug? No, where you usually see this plug?
Like in commercial building
Factories.
factories.
Okay, interesting. Alright. Never seen it in any house? In any kitchen? In any bathroom? Not that you remember. Alright, fair enough, good. So this is really called a Gfci, so it's really a ground fault circuit interrupter. Now, this receptacle or plug is mainly found in area that is exposed to water. So kitchen, bathroom should not have the regular plug, but it should have a plug that has ground fault protection. So in case any liquid or water gets inside, what it will do, it will operate the breaker. The breaker will trip. Right? So so in you doing any installation, this is the type of plug that you would have inside of a kitchen or the bathroom. Now, if it is that you have a water source here, your water pipe is here, or your sink is here inside the kitchen, how far away can you put the GFCI outlet? Based on the regulation, it should be at least 5 feet away from where you have the water source.
5 feet away from where you have the water source?
Yes. At least 5 feet away from where you have the water source.
Maybe the sink, maybe 5 feet away from the sink.
5 feet away from the sink. 5 feet away from the face basin. Right? Yes. If it is that is not the case, the government electrical inspector is going to give you a problem, because it is not according to the regulation. So this one looks like the regular one that you're accustomed to, don't it? Right, so this is the one that we're accustomed to. So how many wires are here? 1, 2, 3. Good, 3 wires. Now, so this is a 15 amp plug, regular plug, where you plug your TV and your fridge and thing in. Right? So what's the color here? You have a what?
Brown.
This is black.
Oh, black.
And you have a white.
White.
And you have what?
Green.
Green. Does it follow the color code according to the regulation earlier? You can go back to it, look at it, you have black, you have white, and you have green for the ground.
Yeah, black are live, white and neutral, and green and brown.
Good, alright, so you follow. Black is alive in this case.
So I keep thinking about red,
Yeah. I know, first, because there is no red here. So black is alive in this case, the white is the neutral, and you have the ground, which is green. If you look, it's really a standard, If you should get one of this, you'll always find the ground somewhere right here. And you have the neutral and the live on either side. No. I remember I said something about these two before. You realize the dimensions are different? You remember what I said about them? What did I say about the shorter one?
The short one is for water.
The dimension, so you have this longer side and you have this shorter side.
Okay, live and neutral. So.
Live, so which one is the live?
Live is the longer side. No, I mean the neutral is the longer side.
The neutral is the longer side,
Yeah.
and the what? And
Live
the
is
live
the
is the shorter side. Alright, good. So you remember that much. Excellent. So I'm going to show you one more. If it is that they are not labeled, there's one more indication that you can use to actually know which side is the live and which side is the neutral. What does here look like? What's the color of this section where you have the live?
The brown.
Look brown. So it's actually copper, it's gold. Right? So on every receptacle that you look at, it must have a what? A copper or a brown section, and it must have a next section over here which is silver. And the same thing goes for your broad-based receptacle for the the socket that you screw your bulbs into. Its connection point will be a copper-looking one section and a silver-looking section. All the time, what happens is that the copper-looking section is the section that is live. So if it is that it's not labeled and you're only seeing silver, copper, and a green or blue head screw, you know that the copper would be where your live connection goes. As in the case most times with your receptacle that you put your bulb into, most times they are not labeled. But how do you know which is live? The copper. So that's a rule of thumb for you to always remember. How do you know that is neutral? Silver. Then suppose you have silver on both sides.
That's possible, sir.
Yeah, I mean you have all different types of suppliers and products buy all over, so it might happen. And I'm not sure if the regulation really look out for things like that. But what will happen is that you'd have to depend on the labeling. Well, you can depend on this to say which side this is on to find out which side is the live. Seeing that we already established that the shorter one is really the live. But if both are the same size, the same metal, you'd have to depend now on the labeling. Right? You'd have to depend now on the labeling. No, so that's the basic for the regular receptacle. So this is really the screw hole. Generally this hole is for the plate of the plug to be screwed onto it, so you can have the nice neat finish. And these are really, this is where you have your ground connection goes in. So your appliance, this round pin on your male plug is usually for the ground. You follow that though, right? Good. So I can show you. Well, if you probably look at the machine that you are at, if you plug out one of them, you realize the round one will be your ground, and you're going to have your live and your neutral. So that's the basic components for it, basically. So similar to here. So if this is the only thing you're seeing, you know that this is the outside, this is the neutral, and this is your what? Your ground. And you see the same configuration being used here. You have your what? Your black, white, green. Nothing wrong with that.
When them wire them thing they plug.
Yes.
You know, I see them use the live on the live on the neutral on the.
Okay.
Good up field.
No, you need to ensure that your ground is connected. So it's 3 wires that they should actually pull. You must pull a live, you must pull a neutral, and you must pull a ground wire. Because if it is that there's a fault in the plug and the ground is not connected, because the purpose of the ground really is to dissipate the fault to earth. Right? But if this is not there, what will happen is that when a fault occurs, it's going to go straight to your equipment. And if there's no equipment for it to go to, what will happen? Fire. So this is important. Earth is important. Talk about the switch now. Familiar with this, right? Regular switch that you have where you turn on your light at home. How many connection points are usually on your switch? 3? 3. Alright. So what? This is one. And what? This is another. And you have a next one up here. Good. You realize with this connection and this connection, both are what? Copper. Both are copper. And with this one here, that look like silver. Right, but how the switch operates for the single pole switch, it's really one wire that goes to the switch. And if you remember our drawing last week, so the live wire goes continue here and it goes to your switch. Right? And then it continues to your bulb, don't it? And your neutral wire goes straight and go to this section. Right? You have your live, I have a neutral, and of course you carry your earth. I'll link it to some frame here. I have your earth. Now, for the basic principle of how you connect your switch, only one wire that you need to break for your single pole switch. And it is really the live wire. So the live wire that comes from your breaker, it goes directly to here. Right? This is where your live wire goes. And then you connect from this section to your lamp.
This is the live wire goes.
The live wire goes directly to your switch.
Yeah.
It goes right here.
To the power wire contact.
And right to the power wire contact, and then it leads your load wire. Then you connect wire from your load wire goes to your lamp. Let me draw it over and include probably this switch.
Two wire that them too.
Sorry?
Two wire.
Yeah. Well, it's two wire that is connected there. So let me do it now. So from your breaker, the live wire goes here. Fine? And you tighten your screw and you connect it there, so. And then you have a left from right here, so now.
And next wire.
And goes to your lamp.
Oh, the different wires.
Different wire here is, but it's same color. So the color I'm using here is red. Right? Same red color. Because it's showing that it is live. The only thing the switch does is just break the power here. That's all the switch does. No, and this is coming directly from your breaker. Now within your breaker panel there is a neutral wire as well. Where does the neutral wire go? The neutral wire doesn't have to go inside here. Neutral wire can go directly to here.
The other side of the bulb.
To the other side of the bulb. But the neutral wire is not broken. It travels directly to your bulb. You see? Now, there's a next wire that must go here, and it is your earth bar, your earth wire. Right? So your earth wire goes and it continues to connect here. Fair enough? And then you can leave it from here and it goes and connect to the earth connection and the bulb. Earth. Follow? So for the single pole switch, only one wire you break, and it's really the live wire.
So this switch really break and carry the current.
That's all it does. It just break the wire and connect it back. So you shouldn't have to connect a switch at all. Or at least understand the principle by which it works. Get that? Get it? Alright, so this is for the single pole switch. Then suppose, no, I'm not going to do the double. I can do it, you know. For the double pole switch, I have an next copper here and a next copper there. You follow me? For the double pole switch, and this wouldn't be single anymore, but this will be double. Now, for this case, with this type of switch, it's really for 220 equipments. So instead of breaking one line, it would break both lines. So from the breaker, you'd have a double pole breaker. Not the first time you're hearing about a double pole breaker. Or 220 breaker.
220 breaker.
Yeah, double pole breaker, right. And I'll show you one as we continue. I'll show you one as we continue. So for your double pole breaker, double pole, DP, double pole, right? Breaker. Now this breaker has two live wires. So in the case of my AC unit that needs 220 VAC. Your AC, my AC for my bedroom, I need 220 volts to it, right? Good. So I leave my double pole breaker with how much wire? So I gotta have live 1, L1, and I got next one we call L2. Right? And I gotta have one neutral. And I gotta also have one earth. You follow me? That's for my 220 volts system. Or for my AC. So I need 2 live. I have to carry the neutral same way in order to complete the circuit, and I must run my earth. Now what goes to the switch? These two goes to the switch. So this one goes to one side. You follow that? And this other line goes to this side. Good? And then this goes to what? To my AC system. Then this to my AC system. L1, L2. What else is missing from my AC system that needs to be connected for this circuit to be complete? Need neutral. Where does the neutral go? Neutral go directly to my AC system. What else is missing again? The earth, where does the earth go? I am going to walk my earth. Right there. I follow? Earth have to go there, son. Because the switch need earth, don't it? And then we are going to continue with it. And connect it to my unit. It's our earth.
So the unit have earth connection too?
Yes.
All unit carry earth connection?
Yes. Most of them does. Or even if they don't, if it's one connection point, well, it has some metallic component frame and the frame of the unit. Your earth can always be bonded to the frame of the unit. So what you find most time with the units is that the neutral and the earth, they are bonded together. That's fine. A matter of fact, inside of your electrical panel, right? The neutral, if you have a neutral bar here, and you have an earth bar over here, what you're going to find, you can check out any electrical panel, you're going to find that they are bonded. There's some connection between both, the neutral and the earth.
But sometimes some of the sub-panel are different. They have some the panel the neutral rather than come narrow beside the breaker. The breaker being the one you send the video you send
Yeah.
the gentleman and everything. Being the earth rather to the side of the breaker and then the ground
Top.
the side.
Yeah, that's fine.
And some are one on the bottom.
Good.
How much space you want to leave for the breaker.
Right. So if you look at it, most times for the main panel, the earth will be connected directly to the neutral. They are bonded. So even if you go down to the equipment stage where you have the AC and them only have 3 connection points, the earth and the neutral can always be connected together. But what is important, what we're looking at now is the fact that what the switch breaks is really the live connections. There are some switch that will have the neutral connection in it too, but it does so be the case, you're just simply, instead of connecting the neutral straight, you just run it through the switch and then to the equipment the same. Alright, so I hope that has been that is clear. Right, so we will definitely.
I understand it, sir, but to get the drift right, that's what can do for
Right. So let me move so too. Right, so this is really what just a photo of what the broad-based receptacle looks like. Single versus double pole. We talked about this earlier. Right, so we're going to pause here and then we're going to pick up and talk about the single pole versus the double pole breaker.